Okay, this video is it's April 16th. It's Mrs. Wilkoskis. This video is on conjugate acid-base pairs. This is the end of section 16.1, starting on page 384. Okay, the Arrhenius concept of acids and bases is based on H plus ions and OH minus ions. Okay, and remember we talked about that was the old definition of acids and bases, the first definition of acids and bases, and then the Bronsted-Lowry expanded that concept of acids and bases, and instead of just thinking H pluses and OH minuses, it was a Bronsted-Lowry base, a Bronsted-Lowry acid is an H plus donor, which is like an Arrhenius acid, but a Bronsted-Lowry base is an OH minus acceptor, an H plus acceptor. Okay, and the conjugate acid-base pair is based on this theory of acids and bases. Okay, so and I think that's somewhere on your review packet, so kind of pay attention to that. So we're going to just talk about this real quick. You already know that this is an acid, and we identify it as being an acid because it is has a acidic proton, acidic hydrogen at the beginning of the formula. And probably learned about this a couple chapters ago when you learned about naming compounds. If there's an H at the beginning of the formula, it's usually an acidic H or an acidic proton. Remember, an H plus ion is a proton. Alrighty, so you might have a question like this that asks you to identify the acid, identify the base, and the conjugate acids and conjugate bases. So what I want you to do is find when you're doing a problem like this, is find the species, is what the book calls it, but I think of it as the particle that is related. So the related particle here is this one right here, okay? And it had to give up an H plus ion. It gave it away. This one had to accept. Let me see if I can mess with the focus real quick. There we go. I think it'll stop jumping around. This will have to accept an H plus. Okay, this gave it away. Okay, this donated it. So that makes this the acid. This had to accept an H plus ion. So that made this the base. Okay, and an acid makes the conjugate base, and a base makes a conjugate acid. Okay, so that's how you do your acid-base pairs. Now, the questions in the bottom of page 385 look like this. I think the question asks, which ones are, let me find it, which of the following represent conjugate acid-base pairs? Okay. Are they related by the removal or gaining of an H plus ion? Yes. So this is an acid-base pair right here. Okay. Or an acid conjugate base pair. Okay. Are they related by the removal or gaining of an H plus ion? Yes, this is. These two species, if you take away an H plus ion on one of them, you don't get the other one. So this one is not related as a conjugate acid-base pair. So that's how that works, and I think there's some questions on the review packet like that. Okay, on the next page, they actually did these problems, so I didn't want to exactly do the same thing. But the question asks is write the conjugate base. So if you're starting with an acid and you're trying to find the conjugate base, add water to it. Okay, and you know H water, because it's amphoteric, is going to grab that extra H, and it becomes HSO4 minus plus H3O plus. So if this is your acid, this is the one that's related to it, this is your conjugate base. So that was the conjugate base for that type of problem. There's a couple more problems at the top of 386 like that, and that's about as hard as it gets. On your review packet, I think this is a worksheet, a classroom worksheet that you were given on Friday. So I'll just do two of these so that you know what we're doing. And I'll do an odd one. This looks a little bit different. I'm trying to think if there's anything else that looks a little bit different. No, acids are usually pretty standard. It's the bases that can look a little different sometimes. So we're going to do number 5, HCN and H2O. So HCN, to get over to its related particle, had to give away an H plus. It had to donate it. So that makes this the acid. Okay. H2O had to accept that H plus ion. That makes this the base. Okay. The acid's always related to the conjugate base. The base is always related to the conjugate acid. And the reason, if you think about it, is if you have to go back, it had to donate it back, and that makes it an acid. Okay, then we'll do number 6 because that looks a little bit different. You're looking at these two. You got to figure out how is this one related to this one right here. That's the related species or the related particles. It had to gain or accept an H plus ion. If it accepted a H plus ion, a proton, it's a base because it's a proton acceptor. Okay, H2O here had to donate an H plus ion, so that made this the acid. So the acid creates a conjugate base, the base creates a conjugate acid. And notice, just as a reminder, H2O, H2O, here it acts as an acid, here it acts as a base. What does that make it? Amphoteric. Okay. If you have, I'm going to keep posting videos throughout the day as I work through the chapter. Let me know if you have any questions.